Okay, Assalamualaikum and very good morning. So to continue with our lesson, so last week we have stopped here on this particular example, okay, where we have hopefully, yeah, this one. Okay, so this is for y equal to 6 minus x. Okay, so now next we are going to, I'm going to explain, okay, how we can sketch the graph of a linear equation, and the total number of equation that we have is 2. Okay, so now we go to the second one, which is the question that I'm asking you to do in the Padlet. Actually, that is one of the way for me to ask you to do first, and then we just compare our answers so that you have more clear about that. Okay, it's okay if you done something wrong, you don't really sketch very well. So because this is, I will say that this is your first time, so it is something not so easy to be done. But once you have, you sketch again and again, I'm sure that you can do it better. Okay, so the next question is in the Padlet. Okay, I follow the numbering in the notes, where the second one we have the equation of 2y equal to 4z plus 5. Okay, so in this case, the equation that we have is the total variable. There is 2, y and z, and then there is no x here. Okay, so as I mentioned in the previous example, if you have the total variable is 2, you have one trace, a single trace, okay, and then the trace is the sketching on 2D. Okay, then you might wonder on which plane that we have to sketch. And since in your equation now, since we are talking about trace, so your sketching should be aligned. Okay, so the trace is part of the procedure for you to obtain the 3D sketching. So now we are thinking about sketching on 2D. So on which plane? So since we have only y and z here, or zy, so your plane is only z versus y or y versus z. So it is up to you. You want to have z versus y, where your z becomes your vertical line, and then your y is your horizontal line. So it is up to you. You can choose your own dimension. I mean orientation. So let's say I want to have so let's simplify this equation first to be in a general form of linear equation. So we have y equal to 2z plus 5 over 2. Okay, so now this is your y versus z. But if you want to have z versus y, also possible, but then you have to convert to be for z equal to 2y minus 5, and then z equal to y over 2 minus 5 over 4, also possible. Okay, so now let's talk about this one. Okay, I'm not saying this is wrong, this is also possible. Okay, so here your slope is positive, so you have a positive slope, which means that you have to extend this, and you can also extend that. So your sketching something like that. Okay, well, we know that the y-intercept here is 5 over 2, and then you have to find out this one, where you should assume that when y equal to 0, so now we are getting z, so 2z plus 5 over 2, and you have 2z equal to minus 5 over 2, so z is located at 5 over 4. So now you have 5 over Okay, so that is your trace. So now that's time for you to, this is trace. Trace is one of step for you to get the 3D shape or 3D curve. Okay, so now we are converting into 3D where we have this. Okay, so then in terms of orientation that you want to use, so you can choose any direction, any orientation that you feel okay, and for you to for you to sketch easily. Okay, so let's say I'm choosing the orientation as in the trace where this is my Y and this is my Z. Okay, and then now we sketch this blue line, which means that we have to extend the line. Okay, and the blue line is there. Okay, and we have 5/2 here minus 5/4. Okay, that is the line which they are should be parallel each other. Okay, so remember here, what is actually happens here? What is the differences between the trace and the sketching on 3D? So actually here, as I show you the example, the previous example, this one is your vision that you can see in your mind. You can imagine something pop up in your mind on 2D. So you can see this one from x-axis. So why x-axis? Because the x-axis here missing in the original expression. So meaning that on the trace, we assuming that we are looking from x-axis where x is equal to 0. No x meaning x equal to 0. Okay, so meaning that for any points that satisfy the y and z, x always equal to 0, right? Okay, so now when you convert into a 3D, which is something that you can touch, the reality, the original graph. So meaning that since you have y, you have z, meaning that this one's supposed to be x. Okay, so for me to easy to explain to you, so now we are assuming that when you are sitting over here along the x-axis, so sorry, so you are sitting over here and you see over there, and you can see the line, this line in your head now, meaning that you are sitting here. So in your mind, your vision, you can see this. Okay, so now we want to provide the plane where you can touch. So in order to get that, you have to apply the projection procedure. Okay, so how can you obtain the projection procedure or the step? You have to imagine in front of you there is a new y and z axis. So meaning that what you have to do here, you are assuming that in front of you, so there is a new y and z plane. Okay, and you draw the same line, and that line should be parallel. So this is your new y and z. So meaning that your blue line on the new yz plane, so for you, you have to use a ruler. So that is the line. Okay, should be parallel. And this one intercept at 5/2, and this one intercept at 5/4. And then in order for you to complete the line, so you have to sketch the projection line. Projection line is the line which is parallel to the axis that you are sitting on. Since you are sitting or you are standing right over here, which is along the x, so you have to draw a line. So here I'm using the different color. Projection line is the line, again take your ruler, and should be parallel to the x-axis. So this is your x-axis, right? So you have to take a ruler and make sure the line is parallel. So that is your projection line. And then to get another line, so that is your projection line. So on this plane, there are a lot of projection lines, and they are all always parallel each other to the x-axis. So this one is your plane. Okay, which means that you can also see the blue line parallel each other. This one, that one, that one. Okay, so it looks like not parallel. So I told you, you have to use a ruler. This one. You can put very many lines, but again, you don't need to waste your time. So it's enough for you to just provide the 2 lines for the blue one and 2 lines for the green one, just to complete your plane. Okay. Okay, so the next example, which is the next question in the Padlet that I give you. You have to sketch the, okay, see, you have z plus x equal to 4. Okay. Actually, this one is just like the first example that we discussed last week, where at the question A we have y equal to minus x plus 6. So now for this, the C, so we just modify. You can have x equal to or z equal to. So let's say we have z equal to minus x plus 4. So the graph looks like similar, but then your plane is different. Now you have zx plane. So now in order for you to sketch the plane on 3D, so we have to provide the single trace. Why single trace? Because you have only total variable is 2. So only one trace that you have to provide in order for you to sketch the 3D graph. So your trace should be lying on zx plane. Zx plane. So based on the equation that you have here in general form of linear equation, so your graph is, you have negative slope, so it should be like that. Okay, so we know that this one is 4 and this one also. So you set z equal to 0, you got minus x plus 4, and then x equal to 4, so you got 4 here. That is your trace. Then when you convert into 3D, okay, let's say I want to maintain the orientation as in the trace. If you want to change, it's up to you. Okay, doesn't matter. It's still correct. But as long as follow the correct, the correct step, you have to provide the correct projection line. You have to make sure that your projection is also correct. So now I'm just use the same orientation as in trace. So z is x, and then this one's supposed to be y, and then where are you on this 3D? So since in this equation there is no y, so meaning that you are standing along the y-axis. So you are standing here and you are facing on the x-plane, then you can see this line. So now we draw again the same line, and they must be parallel. That one. Okay. So this line and this line, they are exactly the same line. Okay, but different dimension. This one 2 dimension, this is 3 dimensional system. So you have this 4 and this is 4. So now how can you get a plane? So just like the first example that we discussed last week, you assume that in front of you there is a new z and x. So z and this one x. So again, take your ruler to make sure that the new line that you want to sketch must be parallel to this line. So you have 4 and this is also 4. Now, how can you complete or get the plane? So you draw the projection line. The projection line is a line parallel to the y, because you're sitting over here y, so meaning that that line should be parallel to y-axis. So you just draw the line here, and just draw the line here. So that is your plane. So that is your plane. So you might wonder whether do you need to provide these lines, so many lines. So no need. Okay, actually if you just want to shade the region where is your plane, actually if you have more time, so you can just sketch, maybe you have to just maybe using highlight this one, so just like that, but I'm sure that you have no time for that. Okay, so that is your plane. Okay, so that is the step needed when you want to plot the linear equation or the equations where the total number is 2. Okay. Okay, so now by looking at the next example, so look at the slide of the lecture note. So the next one is the equation, still linear equation, where the total variable, there are 3, and there is 3 total variable. You have all of them, x, y, z. Okay, so now again the step. So the step is the same as the 2 variable here, which means that you have to provide the trace, and after that you have to convert into 3D. But now because you have extra variable here, which is 3 now, so your task is more longer, which means that for this one, this is very important, yeah. This one you need only for 2 variable. This one you need 1 trace, single trace on which variable exists in the equation. Now you have yx, so meaning that your trace on yx, that is only 1 trace. Similarly, the second one yz, so your trace should be on yz plane. This one zx, so your trace should be on zx plane. Okay, so now for this particular function where you have 3 variables, so now still this step contains the trace, but now you have to provide 3 traces. 3 traces. And then what you have to do, you based on the 3 traces that you have sketched and provided, then you have to combine them all together. So for so after that you can get the plane for on 3D system. Okay, so how can we now I want to show you how can we sketch the first one here. Okay, so now look at the first example where you have x plus y plus z equal to 1. Okay, so 3 traces. How can you have 3 traces? Okay, remember traces is your sketching on 2D. So you got 3 here, right? And how can you obtain just 2? I mean, whether xy plane or yz plane or zx plane. Then so to obtain the traces, so you have to provide the 3 of them, meaning that okay, I want to see what can I see when the line, I mean the graph is on xy plane. So you set up y x plane. Okay, next I also want to observe what is the shape or the curve when the plane is on for example zy plane. How about the third one? So now you have yx, which is z equal to 0, right? For this one, it's happened when z equal to 0. You set y equal to 0. So you have only y and x. So How about the second one? You have zy, meaning that there is no x. So on this plane, actually the x is always equal to 0. And the third one, can you explain next? What happened? What is the plane that we should have? Yes, since we have zy, we have already yx. So meaning that the third one is zx, where that one, the point here, the point lies along this plane. The y is always equal to 0. Okay, so maybe you want to ask me, do I need to follow this follow the same order, meaning that yx first, then followed by zy first, and then z. No, it's up to you. Okay, so this is mine. So if you want to choose zy first, so it is up to you. Then if some of you want to start with the zx, so it is up to you. As long as you provide the 3 traces, so you're definitely correct. Okay, so now what is the curve? How can we get the curve? So meaning that when yx plane, the z is always equal to 0, what you have to do is, we are assuming when z equal to 0 here, this one is 0, so you have x plus y equal to 1. So now it's reduced into 2 variables. Total variable is 2. So now you can have y equal to or x equal to, let's say I have y equal to minus x plus 1. Okay, because I put the y over here, so I set up y equal to. If you want to put x over here, then you have to provide x equal to. Okay, so we know that our graph is negative slope. So we have this. And the interception very important. So we know this one, this is 1. Okay, so I'm sure that you know how to get this, so I don't want to explain that. Okay, so next, go to the next trace. The next trace, this plane, meaning that x is always equal to 0. So how does the curve looks like? Then back to the original equation here. So we set x equal to 0. So when x equal to 0, so the equation becomes y plus z equal to 1. So we have z equal to 1 minus y. Okay. So then, again, negative y plus 1. We have negative slope. And the intersection is 1. And this is also 1. And for the next trace, the last trace, we set the equation become where the y is equal to 0. Then we substitute into the original expression here. So we have x plus z equal to 1, then z equal to minus x plus 1. And we got that line. So actually you can see the line exactly the same size. It just coincident, depends on the equation that you have. It's not always the time like this, okay? So don't memorize, please understand, okay? So this one 1, this is 1. Okay, so we have already provided all the 3 traces, okay? So then your task is to combine all of them into a single 3D system. So using all the result, then you have to sketch the 3D graph. Okay, so how can you do that? If we revise back in the previous example, when you have the total variable is 2, you have a single trace, right? Which is based on the equation that we have here. Let's say we start with the first trace, so this one. So you have only y and x. So meaning that this plane, the z is always equal to 0. Now, in terms of sketching on 3D, what you have to do on the previous example, we are assuming that we are looking along the z-axis. So, along the z-axis, so let's say I'm using the standard orientation. If you want to change, it's up to you. Okay, I want to fix on the standard orientation. So, meaning that, okay, how can you have y-axis plane? So, where is your y-axis plane? Your y-axis plane down here. Your y and x down here. So meaning that this green line should be located on along this plane down here, right? Okay, so on y-axis, so you draw the green line. So that is your green line. So you have one here, and this is one. Okay, so, and actually this is the line. So where are you now? When you can see that line in your mind now, or in your head, so where are you now? So you are sitting over here, and you're looking down, and you can see this green line, where now this is inside your head, inside your mind. You can see this one. Okay, and then we move to the second trace where zy plane. So what is zy? So z here, so that is your z, and that is your y. So, and then now sketch again. Sketch next on the curve that you have on zy. So you have the green line also intersecting at z equal to 1, and also on the same point here when y is equal to 1. So you draw the line. Okay, so make sure you intercept, because the value on y at 1 here, the intersection on y-axis also 1. So make sure that you are intersecting the same line as on xy plane. So you got the point here. This is 1, and this is also 1. And next, the third, okay, on zy. So meaning on this 3D system, so where are you now? Where are you? You are standing over here, and you can see to that plane zy. So this is the line where you can see. Now this is your vision now on 2D, where you can see from from x. Okay, now the third trace on zx. So what is zx? zx. Okay, now you have z here, x down here. So your line also intersecting at z equal to 1 and intersecting at x equal to 1. 1 here and 1 here. So make sure your line is intersect with the two lines over there. Okay, so that is the combination of all the 3 traces. So now, what is actually your plane looks like? Where is your plane? Which is a surface. So your plane is this one. A flat plane, but in that particular form. So for your information, this is not just triangle like this. Okay, so there is a special name for this particular graph, which belongs to the linear equation when there are 3 variables in there. So this graph is called as tetrahedron. So what is tetrahedron? Okay, actually this plane is very, very large. The size is very, very, very large. But the special of this kind of plane, it's just like a flat plane that we have. This one, flat plane. So this is the maybe z equal to 5. Okay, and this one is maybe x plus y equal to 1, because there is a slope. And now for the tetrahedron, also a plane and there is a slope, but then the special of this particular plane, it is passing through all the wall. So remember, so if you have a standard orientation, so you have this wall, this is called front wall. So please look at again, rewatch or replay the video that I have shared where there is a discussion about the graph of 2 variable function. Okay, so this one is called front wall, and this one is your side wall or left wall, and down here is floor. So the special property of the tetrahedron is actually the plane is passing through all the wall, the front wall, the left wall, and also the floor. Okay, as I mentioned just now, so this plane is actually very, very large. So I have this sketch here, very, very large. But then the special here, that plane intersect at the wall. Okay, this is the imagine you are in your bedroom, for example. So you just look at the end of the corner. So you are in your bedroom. Okay, so this is your wall, and this is another wall, and this is your floor. So the plane is intersect, or intersect with all the wall and the floor. So that is called tetrahedron. Where actually, for your information, tetrahedron is something a bit complicated to sketch by hand. Okay, just a few of the equation that can be sketched. Sketched by hand. So meaning that if the question in exam asking for the tetrahedron, so that is not so complicated. So your task is only to provide all the three traces. Okay, provide all the three traces that you have sketched. 1, 2, 3. You assume that z equal to 0, x equal to 0, y equal to 0. Then you combine them all together on a single 3D system. So make sure that all the lines that you have, they are intersecting on the similar point. So let's say you compute, okay, you provide all the three traces, and when you want to join them all together, so one of the line you got this one. Well, let's say this is 1, this is 2, but then the second line, so let's say this is x, this is y, and this is z. Now you want to sketch the second line, but the second line, the intersection on z is different. So you got, let's say, 0, 1 over 2, and this one is 3. So you can see that the two lines here, they are not intersecting each other. So meaning that this is wrong. It cannot be like that. Okay, maybe you have to recheck. Okay, double check your calculation in finding the traces. Maybe you did something wrong. So it cannot be like that. So the tetrahedron, the intersection point should be on the same point. There must be an intersection point. Okay, so that is a tetrahedron.